Welcome to Maths Video Tutorials. Welcome to this tutorial in which we'll be looking at radians. We will learn what a radian measure is. We will learn how to convert between radians and degrees, and also learn the formula for the arc length from scratch, and also the area of the sector. We learn how to recreate the formula from scratch. And after that, we will answer some exam style questions on the arc length and the area of a sector. We have got a lot to do, so let's get started. Now, the formula for the circumference 2 pi r tells us that the circumference subtends an angle in radians of 2 pi. And we also know that a full circle is equal to 360 degrees, meaning that 1 pi radian is equal 180 degrees. You divide by 2 both sides. From here we can say that 1 radian is equal to 180 divided by pi. You just divide both sides by pi. Now, by doing the inverse, if you do the reciprocal, you will change from degree to radian. So we can write down 1 degree is equal pi over 180 degrees. Or 180. So these are the two formulae that will allow you to convert from radian to degree and from degree to radian. I should put a radian here. Radian. Now, for the formula of the arc length, we know in degrees that the full circle circumference 2 pi r. Now, if you're calculating the length of an arc L, in degrees is the angle of that sector of the angle that is subtended by the arc, I should say, divided by 360 and multiplied by the formula for the full circle, which is 2 pi r. Now, in order for us to convert this formula in radian, what we have to do is just rewrite 360 as 2 pi, because remember, as we said earlier, 360 degrees is 2 pi radians, so that's what we did here, and multiply by 2 pi r. So you can see clearly these two will cancel out, leaving us with our little formula in the radian of the arc length, theta r. And that's the formula we're looking for. We do the area of the sector next. For the area of a sector, we're going to start, of course, from the area of the full circle. We call it capital A as a pi r squared. We know that. So for a sector like this one here, in degrees again, the formula will become similar to this one here. The angle of that sector in degrees divided by 360 times the formula itself of the full circle, pi r squared. Again, similar as we did earlier. To convert this formula area of a sector from degrees to radian, we need to write this 360 degrees into radian, 2 pi. So let's do that. 2 pi times pi r squared. Now here you can see the pi will cancel out with pi. We'll be left with theta, not pi. We cancel the pi. We'll be left with the theta, the angle, in radian now as r squared divided by 2. So we can write it down as area of a sector. We'll write down sector is equal half theta r squared. So this is our second formula. Maybe a good way to explain or to give a definition of the radian measure of an angle is to go back and compare it to the degree measure of angles. In this example or diagram, we have an angle 45 degrees, and you can see the degree angle is the amount of turn you are making from this side or arrow towards this arrow there, following this arrow there. So an angle in degrees is the amount of turn you're making. How about for the angles in radian? What are they? So what is a radian measure? If we take any circle with center C, and from that center we draw 2 radii to form an angle, the length of the radius is r, to form an angle theta. Our angle theta will cross the circumference to form the subtended arc. We call it L. Now, we learned in this tutorial that the arc length is given by the formula L equal r theta. If we take this formula, we rewrite it to make theta the subject, it will become L over r, the arc length divided by the radius. If we look at the formula, we can conclude from it that the angle in radian is a scale factor length divided by radius. So it is a scale factor which compares the subtended arc to the radius. Another conclusion we can make from this formula of the angle theta measured in radian is that if we make the subtended arc equal to the radius, so that is if L is equal to r, then you can see theta has a value of 1 radian, of course. And we know from this tutorial that 1 radian is equal in degrees to 57.3 degrees. And lastly, if we take the radius and make it equal to 1 unit, that will give us the formula theta equal L, the subtended arc. Alright, we have come to the end of this video tutorial. I hope this tutorial was very helpful. Thank you for watching and take care.